Hello guys, today we will discuss some more problems. So he has given that a 35 millihenry inductor is connected in series with 5 microfarad capacitor and it is further connected to 3 plus J6 ohms impedance. So he asked to calculate the supply current and the current in each branch and also the supply power if the voltage is 50 sine 2000 T. First we will draw a circuit for this. So he has given a voltage V of t. V of t equal to 50 sine 2000 t. 50 sine 2000 t. This is the voltage, and he has said that 35 millihenry inductor. So I am drawing an inductor. It is connected in series with 5 microfarad capacitor. So 5 microfarad capacitor. It is connected in series. So I am mentioning that it is 35 millihenry inductor and 5 microfarad capacitor. 5 microfarad capacitor, and it is connected in parallel with a resistance 3 ohms, and XL value also he has given as J6, no, so plus J6. So I am drawing it as an inductor. So this is J6 ohms. So 35 millihenry inductor is connected in series with 5 microfarad capacitor, which is connected in parallel with 3 plus J6 ohms impedance. So I am naming it as Z2 and this value as Z1. So we have to calculate the current in each branch, I1 as well as I2, and the total current also IT. So I am assuming that the total current is IT. I1 and I2 are the currents in each branch. So we have to calculate all these, and also the supply power. Power also we have to calculate it. So first we will write the given data. So he has given that voltage is V of t equal to 50 sine 2000 t, no, 50 sine 2000 t. So for 50 sine 2000 t, we can compare with the normal voltage equation V of t equal to Vm sine omega t. So if you compare this with the voltage equation, the omega value will be 2000, and voltage maximum value of voltage value will be 50 volts. So we have to calculate in AC, we have to calculate the RMS value, no. So VRMS value or V value equal to Vm by root 2. Vm by root 2. So VRMS equal to Vm maximum value he has given as 50, you know. So 50 by root 2. So 50 by root 2, the value will be 35.35 volts. 35.35 volts is the VRMS. So we have calculated the VRMS voltage. So we have to calculate the current in each branch, no, I1 and I2. So first we will write the Z1. Z1 equal to, he has given as XL minus XC1. We have to calculate XL and XC1, no. So first we have to calculate XL1. XL1 equal to omega L1. Omega value he has given as 2000, and L1 is 35 millihenry, no. So 35 into milli means 10 power minus 3. So 35 into 10 power minus 3. So the value will be 70 ohms. XL value will be 70 ohms, and we have to calculate the XC value also, no. So XC equal to omega 1 by omega C1. So 1 by omega C1 is the XC1 value. So XL equal to 1 by omega C1. 1 by omega value he has given as 2000, and C value is 5 microfarad, no. So 5 into 10 power minus 6. So 5 into 10 power minus 6. So the value will be, XC value will be 100 ohms. XC value will be 100 ohms. So we can take these values in the Z value. So Z1 equal to 70 minus J100. 70 minus J100. This is the Z1 value, and Z2 value he has already given, no, 3 plus J6 ohms. 3 plus J6 ohms. So we can calculate this value in the polar form also, as it is in the rectangular. So we can convert into polar. So Z1 equal to polar form 70 minus J100 in the polar form. The value will be 122 at an angle of minus 55 degrees. 122 at an angle of minus 55 degrees is the Z1 value in the polar form. So in the Z2 value also in the polar form we have to calculate it 6.7 at an angle of 63.4. So this is the Z2 value as well as Z1 value in the polar form. So we have to calculate the I1 now. So for I1 equal to current in each branch. So I1 equal to V by Z1. So V value already we have known. No? The value of RMS value is 35.35 at an angle of 0. And Z1 value we have calculated it now. Z1 equal to 122 at an angle of minus 55 degrees. 122 at an angle of minus 55 degrees. So it is in the form of R1 by R2 theta 1 by theta 2. So we can convert into R1 by R2 theta 1 minus of theta 2. So 35.35 by 122, the angle will be 0.289 and angle will be 0 minus of minus 55. The value will be 55 now. 0.289 at an angle of 55 degrees. This is the I1 in the polar form. So we can convert into rectangular form now. So I1 equal to 0.165 plus J 0.236 amperes. This is the current value in the rectangular form. So it is in the rectangular form. In the similar way, we have to calculate I2 also. I2 equal to V by Z2. V value already known, 35.35 at an angle of 0. And Z2 value will be, if we convert into polar form, the value is 6.7 at an angle of 63.4, no, 63.4 degrees. So it is also in the form of R1 by R2 theta 1 by theta 2. So if we convert into these values, I2 value equal to 5.27 at an angle of minus 63.4 degrees. This is the I2 in the polar form. So we have to convert into rectangular form. So the rectangular form I2 value will be 2.35 minus J 4.71 ampere. 4.71 ampere. This is the current value in the rectangular form. So we have to calculate the total current now. So total current equal to I1 plus I2. So I1 value we have calculated now. So I1 value will be 0.165 plus J 0.236. This is the I1 value, and I2 value is 2.35 minus J 4.71. This is the I1 and I2 values. So if you add these two terms, the value will be 2.515 minus J 4.474 ampere. This is in the rectangular form. So this is the final value in the rectangular form. So if you convert into polar form, the IT value will be 5.132 at an angle of minus 60.65 amperes. This is the total current in the circuit. So we have calculated the current in each branch as well as the current in the total current of the IT value. IT value we can term it as the supply current and also the current in each branch. The final value we has asked to calculate the supply power. No? So supply power, we have to calculate the supply power. So the supply power P equal to VI cos pi, VI cos pi. So the voltage is 35.35 and the current value is 5.132, no? So 5.132 at an angle of cos of, the angle he has given as minus 60.65, no? So cos of minus of 60.65, the value will be the 35.35 and 5.132 cos of 60.65. So the value will be 88.91 watts. So it is in the real power or supply power, no? So it is in watts, 88.91 watts. This is the supply power. So we have calculated the current in each branch as well as the total current and the supply power. So all the terms we have calculated it in the circuit. Thank you guys. We will meet in next class. Thank you.